My name is Graham. I'm the co-founder of GrowthBook. Can everyone hear me all right? Yeah? Okay. I know there's not a whole lot of you here. Is everyone engineers or software or data scientists? Data scientists? Okay. Everyone knows what A/B testing is? Anyone not know what A/B testing is? All right, so we'll go pretty quickly over the introductory part. So my goal of today's talk is to give you a quick introduction to A/B testing. Seems like we don't need to spend much time there. Then we're going to focus most of the talk on why you A/B test and then some of the experimentation tooling that's developed in the last couple of years. And then we'll go into some best practices with A/B testing and some common problems that we've seen at scale. This is an animal-based presentation. This is my dog, Nellie. So if you don't like what I'm talking about, at least you can enjoy the pretty pictures of animals. So my experience with A/B testing goes back quite a long way. This is me when we were born. Fun fact about me, I'm a twin, and actually a surprise twin. My mom's doctor did not believe in ultrasounds. And so one of the problems when you're a surprise twin is that your parents have one of everything, and including names. So when we were born, we were actually called baby A and baby B. Anyone want to guess which one's me? B? Yes, B is me. Congratulations there. I was still waiting on the success criteria on that test, but so we'll quickly jump into what A/B testing is all about. So the definition I really like of A/B testing is a controlled way of measuring the impact of a change or a feature on real users. And so how that works in practice is you first have a hypothesis, some idea you want to test. You then choose an audience you want to assign that test to. You then randomly split that audience into 2 or more groups and assign them into the different variations, hopefully persistent. You then show them different experiences of your product or application or whatever it is you're testing. You then track how they behave through your application and then use statistics to figure out if those changes are significant. So there's obviously a lot more to it, but that's like a really high level. So let's take a look at some A/B testing examples. So this is an A/B test from Airbnb. And so Airbnb was trying to improve the booking rate by being more clear about the cancellation policies, by giving a timeline of the cancellation window. So raise your hand if you think the new version improved the booking rates. Raise your hand if you think it decreased the booking rates. Yes, a decrease. So well done, you guys got that one right. And I don't work for Airbnb, by the way, I never have, but this is from a website called goodui.org, which tracks A/B tests that it detects in the wild. So this next example is from Netflix. So this is their homepage. So on the left is the original version that has a button that says join now, and then it goes to a second page that has a form where you can sign up for Netflix. The new version is, the version that they tested is basically the same, except instead of having just a button, it has an input box where you enter your email address and then click next. So who thinks this lost to the control version? Who thinks it won? Who doesn't want to vote? A lot of people, okay. This one actually improved performance. Again, I don't work for Netflix, so I don't know exactly what happened, but my hypothesis would be that getting that email address ahead of time, even without context, is probably worth more to them in the long run than a completion rate on a form with context. So why do we A/B test? So let's take a look at that. I'm going to ask you a question in terms of, so we launch features every day. We launch A/B tests every day. How often, or what's the average success rate? And to ask that another way, how often is a feature that you launch successful in improving the metrics with which it was intended to do? So does anyone think it's like over 70%? Over 50%? Over 40%? You guys, 40? Okay. 30%? Yeah. Okay, so so industry-wide success rates for experiments are about 33%. So about 1/3 of the time, the features that we launch are successful in improving metrics with which they are intended, and about 2/3 of the time, they are unsuccessful or actually hurt your metrics. Which is kind of wild to think about because no one launches a feature they don't think will win, right? Everyone's trying to improve their products, and yet we're still pretty much bad at it. It actually gets even worse because the more optimized your product is, the lower the success rates get. So these are some success rates from the industry, Microsoft, Bing, Booking, Google, et cetera. And you really can't get the same degree of information just by looking at, so squinting at the data, right? If you just look before and after testing, this is an example from Airbnb where they rolled out a feature, tracked the metrics over time, and then ended up rolling it back because it lost the experiment. But if you just looked at the aggregate performance metrics, you just can't see the effect of that change because there's so much variance and so much other stuff happening day to day. So the takeaway here is that without testing, you're guessing. And a lot of companies know this. So there's a lot of companies that have figured out like a high degree of sophistication with their experimentation programs. So if we, so on the crawl, walk, run, fly, model, there's usually companies start with just adding some basic analytics. So let's do event tracking. You then start getting kind of into the walking mode where you're kind of running some manual A/B tests. Maybe you're optimizing one part of your product. You're running kind of 5 tests a month. You then start getting into the run area where your experimentation is quite common. You may even have a growth team or some data teams making sure you do experimentation well. You're running anywhere from like 5 to 100 tests. And then you get to the fly stage where you have ubiquitous experimentation, where you get companies running tens of thousands of experiments every month. Everyone at that scale here? Where do you work? Do you mind? Amazon? Okay, that makes sense. Yeah, you have the traffic to do that. And so you might imagine that like the tools that you build to be able to run 10,000 tests are quite different than an off-the-shelf tool. And so what you tend to get is this sort of curve like this where this really sophisticated experimentation tooling requires a large company to build it. And then you get all these companies up here on this end, and all of them self-build. And so into this space, I found myself also building my last experimentation platform and wondering, like, every single platform here is pretty much the same thing, with slight variations on the data and statistics, but really very similar. So why can't we just build a tool that unlocks this sort of ubiquitous experimentation for all companies and doesn't require a team of, I don't know, 10s to 20s of engineers full-time working on it? And so that's really what we decided to build with GrowthBook. So GrowthBook is an open source A/B testing and feature flagging platform. And the idea is to really be an in-house platform that you don't have to build and really unlock that like ubiquitous experimentation. So how that works in practice is that most people here already have data going somewhere, right? You probably have data in a data warehouse. And so you're actually really close to getting that experimentation platform set up already. If you're using any of these event trackers, getting your data into an event warehouse is super simple. But even if you're using something custom, that's totally fine. And so you already have this one box of our experimentation lifecycle already built. And so GrowthBook is a Docker container that you can just run, and it connects to your data warehouse and then gives you a full suite of experimentation analytics on top of that. And we support really any data warehouse that you might have data in. We support connecting to it. And then you get experimentation dashboards like this, out of the box, completely for free and open source. And it comes with like full dimensional analysis and some really advanced features there that are pretty hard to build yourself. We also give full transparency. So behind the scenes, everything is SQL powered. And so we'll actually expose all the SQL for everything that we build. And so if you ever see something weird or some data that looks a little off, you can just go and debug it and figure out what's happening. So now you have the reporting and the tracking side, but then what about the hypothesis and variation assignments? With GrowthBook, you're welcome to do that yourself. We'd have no allegiance to how you build that, but we did build a feature flagging suite as well, which allows you to kind of quickly deploy features and do the variation assignment as well. So in that, you actually get like a full functioning suite, really running on top of your own data for very low cost, like pretty much no cost. Depending on the size of your data, if you're Amazon scale, you're gonna be paying for that data, but then they don't really care about that because they own all the database servers too. So, And then you get like a platform like this. This is what GrowthBook looks like, or at least it did a couple months ago, with a feature flagging platform, and then you can toggle things. You can also do like experimentation assignment through a nice GUI. Yeah. So I could give you a quick demo of the GrowthBook platform where we can go into more of the best practices. Anyone have an opinion? Demo? Okay. Should we try a live demo? This always goes well, right? All right, so here's GrowthBook. You can all see that? A bit bigger. So I have GrowthBook set up, but it's not really connected to a data set. It just has my sample data set here. But I'm going to add a data source. And for this example, I'm going to say I'm going to use Google Analytics. So then I just have to connect. Let's see if this works. So connect to my data source, tell it about the project ID I'm working with. And there we go. So now we're connected to my BigQuery database, and I know that the data warehouse is, or the data is coming from Google Analytics. So I can click on the view schema browser and I can see all my events coming in here. But what's kind of neat about GrowthBook is we added auto discovery of metrics. So we can just go in here and like create metrics, right? Like how many people, yeah, we'll just, I don't know, turn off some of these lesser important ones, but we can just create all those metrics. And now we have 16 metrics that are tied to this data source with literally, what was that, 30 seconds? And so if I go here to the metrics, yeah. So here are all my metrics, so I can click on, like, let's say page views. I can do a quick analysis just to see if it's working. And now when I run an experiment, I can use that page view metric. I can just create new experiments and then add that metric to any of my experiments. And I can even add it retroactively too, which is kind of neat. And then you get an experiment report that looks a lot like this. This is a sample data report that kind of shows you the impact of this change. Yeah, let me jump back to the presentation. Oh. Okay. So the takeaway here is that in 2023, there's really very few cases where you should build your own platform. I would really recommend not doing that. There's a lot of risk in building your own, in that one bug in your statistics and you invalidate all your past decisions that you've made. So the risks are very high, and the upsides are fairly low in terms of using a tool like ours. All right, so let's jump into some A/B testing best practices. So one of the ones that we always like to tell companies that they really need to build trust in your experimentation results. And to help illustrate this, I'm going to tell you a little example about Ignaz Semmelweis. Anyone heard of him? No? Yeah, not really a household name. But Ignaz was a Hungarian physician. He was born in sort of the height of the Austro-Hungarian Empire. And by the 1840s, he found himself basically the equivalent of a chief resident of the Vienna General Hospital. Now, medicine around this time was pretty weird, pretty primitive by today's standards, in that people had no idea how you got sick. They thought maybe you got sick through like bad humors or being immoral or bad air, and they really had no idea. But around this time, they started applying science to medicine, which was sort of pretty new. And part of that included doing a lot of autopsies and looking at data. And Ignaz was no different. And when he was the chief resident of this hospital, he found that he had 2 maternity wards. One of the wards was staffed by doctors, and one of the wards was staffed by midwives. And he found a marked difference in the mortality rates of the women giving birth there. Does anyone want to guess which one had a higher mortality rate? Okay, well, the one run by doctors had about a 4 to 5 times higher mortality rate than the maternity ward run by midwives. And so he was quite perplexed by this. He was like, why would they be so different? So he started looking at maybe the doctor's ward is only admitting folks who are more sick than the ones that go to the midwife ward. Well, that turned out not to be true because they admitted patients on alternate days. So the sample size is pretty much the same, just depending on when you went into labor. The death rate was so high in one of the wards that there were constantly priests walking around ringing bells, and he thought maybe that scared the women into just dying, and so he banned bells, and he had the priests wear slippers, and that had no effect. And it wasn't until a friend of his was doing an autopsy and cut his hand and died of an infection very similar to what his women in his maternity ward were dying, that he had an idea that perhaps we should be washing our hands before going to see our patients after doing autopsies. Pretty wild thought at the time, right? So he had his doctors wash their hands with chlorine, and when he did that, he found that the mortality rates fell by 10x. Right, this is great news. Everyone remembers him because he introduced hand washing into the world. Well, it turns out not the case. Despite overwhelming evidence, the doctors just kind of refused to do his idea. So while he was chief resident, he was able to enforce it, but shortly afterwards, the doctors forced him out and went back to not washing their hands, and the mortality rates went right back up. And it would be another 20 years before his ideas were accepted as part of like the germ theory of medicine. Rather unfortunately for Semmelweis, it doesn't really end very well, because he started writing letters to all the hospitals to get everyone to try to wash their hands, and everyone thought he was crazy, to the point where they tried to have him committed to a mental asylum. And in fighting with the guards, he ended up getting cut on his hand and, rather ironically, dying of an infection. So poor Semmelweis there. But the reason why I tell you this is because there's a concept in A/B testing we call the Semmelweis reflex, which is like a reflective rejection of new information. So quite often when you tell people about the success rates of A/B testing or counterintuitive results, they're going to want to like object against the data. And you really need to guard against that. So the best way to do that is to really build trust in your experimentation platform. And the best way to do that is by being really transparent and like running a lot of AA tests. If you're not familiar, it's basically an A/B test where there's no difference, and you want to make sure that the sides are the same. You should run data quality checks, like sample ratio mismatches, make sure that people aren't being exposed to both sides of your experiment, and being able to audit the results is really important. And then training your team on some basic concepts of experimentation and statistics. This one's a little bit thankless if you ever had to explain p-values to folks, but there are some other ways around that as well. We'll get into some of the common problems in a little bit. Another one that we see people get wrong a lot is experimentation frequency. So let's say you have a winning test and you deployed that to production. What are the odds that it's the optimal design first try? So if you were to plot all possible versions of that product against the performance of those products, what are the odds that that's the highest performing version of itself? It's pretty low, right? Probably close to zero. And in fact, you have no idea, right? But you only have one data point. So maybe you test a different version and it performs slightly better. But now you have two data points, and you really have no idea what this shape of this graph is going to look like. You know, it could be like this. You could be near a localized maxima or not. It could be like this. Like you have really no idea. And so it takes a lot of experimentation to kind of optimize the product and figure out where your optimal values for the various things are. And then you should really adopt experimentation as part of your product development process. I often talk to folks about how they make product decisions. Sometimes people listen to whoever's like the loudest person gets to win. Sometimes we get the hippos, which is the highest paid person's opinion. But you know, we're not really great at predicting what users want. I mean, even with this, we're still only batting 1/3 of the time success rate or less. And so this is how you get products like Clairol Touch of Yogurt shampoo, which was a bit failure. People were eating their shampoo. Walmart just released, I think 2 years ago, they released Juneteenth ice cream and then trademarked the term Juneteenth, which is pretty tone deaf. And then, more recently we have certain people destroying a beloved brand, and I don't know, that jury's still out if that one works. But there's so much focus on like the development process that people often forget about kind of the sides of it, right? Like the ideation side and what does done mean? And so you might be using like an agile process or whatever this is. This is lean agile scaling. Enterprise is just scary. I hope this is not yours. And this is the agile landscape. These are all the different possible project management processes, but all of them focus on that middle box. And really none of them focus on done. So what does done mean? Is it just when we ship it? Is it like that it's defect free? Is it like accepted user stories? Maybe the product owner likes it. Like none of this really matters, because the only thing that really matters is like, did we improve our business goals when we ship this thing? And so each product, when you define it, should really, or each product when you come up with the ideation for it, should define like, what does success look like for this? And so like, what are you trying to do? What are the actions that a user would do to demonstrate that hypothesis? What are the metrics that you would need to show that would prove that action? And then what is the smallest thing we can build to see if we're correct or incorrect with that assumption? The last part is actually pretty important, because you don't want to overinvest in something that doesn't work. And you can test a lot of different versions of something and figure out like, is it the implementation that's wrong or the hypothesis that's wrong? I like to call this ham. I don't know. I haven't had much success with that, but we'll see if that catches on. Yeah, and then only really ship those features that positively impact your metrics or your users. All right, let's take a look at some common mistakes. So number one is peaking. This is where you prematurely make a decision based on incomplete data. Typically, this is most common with frequentist statistics if you're in that space. But there are some ways to guard against this, but the biggest one is to tell people when they're peaking and when they're not, and keep them honest about that. Twyman's law, if you're not familiar with Twyman's law, basically it's, well, by example, let me say that you just launched a new feature and you doubled revenue. Should you celebrate, ask for a raise? You might want to wait on that, because large improvements from a single experiment are actually extremely rare. And you really should do some further investigating to see if that impact was actually a bug or not. Funny story, this happened to me at my last job. It turned out we were just double billing all of our customers, which is a great hack to make more money, but it wasn't great for long term. So Twyman's law is any figure or figure that looks interesting or different is usually wrong. Goodhart's law, so when a measure becomes a goal, it ceases to be a good measure. So by way of example here, around the turn of the century in Vietnam, in colonial France, Vietnam, they had a problem with the plague. And they decided to try to combat that by incentivizing people to kill rats, which are a primary vector for plague fleas, I guess. So they decided to incentivize killing of rats by having a bounty on rats, and they determined if you paid or killed the rat by handing in a tail of the rat. And by all accounts, this was like a great success. In some cases, I think they had thousands of rat tails being turned in a day. Until they started noticing there are an awful lot of rats running around Hanoi without tails. And it turns out that the Vietnamese were just cutting the tails off without letting them go, and in some cases like feeding them to try to create more rats so that they could get more money from the tails. So Goodhart's law is when a measure becomes a goal, it ceases to be a good measure. Confirmation bias. So the goal of A/B testing is not to prove that you're right or some genius. The goal is to make the right decision for your product. So you're not just looking for the metrics that prove exactly what you want to see. Similarly, there's the multiple testing problem. So basically, the more metrics you add to an experiment, for every metric, there's a non-zero chance it might just be randomly better. And so if you keep adding metrics until you find one that you see goes up and then declare it a winner, like that's metric shopping, and you shouldn't do that. How are we doing on time? 5. Can't read what that says. 5 minutes? Cool. All right, so in conclusion, if you're not testing, you really should be. You're basically guessing at this point. A/B testing is more accessible than ever. There's some really great tools out there that allow you to run it with your existing data for literally zero cost or essentially free. And then you should apply best practices. So you should be testing a lot. You should be building trust in your experimentation platform, and then make experimentation part of your process and team culture. Avoid some common mistakes that I just mentioned. And then hopefully with all of this, you can make better product-driven decisions, or better decisions, and increase transparency and trust in the decisions that you make. And above all, like, don't forget poor Semmelweis. Be open to new ideas that challenge your assumptions. Finally, if you're interested in A/B testing and you haven't already read Ron Kohavi's book, I highly recommend it. He was at Microsoft and Airbnb and I think Amazon as well. Built a lot of their platforms. GrowthBook, we have our own testing book that's open source and based on particularly our platform. Yeah, thanks.